Всем привет! Мы продолжаем учить промисы и асинхронщину. Сегодня у нас 40 страниц про промисы. If you press well in your search, trouble promise, trust bill, chain flow, reject, yoki-poki. Peering disappearing, code handling, peering success, promise patterns, promise all, promise race, timeout race finally, owner race, concurrent iteration, promise IP recap, your promise constructor. Learning catch, promise and promise race. Value, splitting value. Yeah. The callbacks. You go deep into the how and why of promises. The chapter is not the easy read, but you will be promised professional if you take the time to properly digest. It's worth the effort. Да. Нет, я читать не буду. Что читаем? You don't know jazz singing performance promises. In chapter 2, we identified two major categories of deficiencies with using callbacks to express programming synchronous, asynchrony and managed concurrency, and lack of sequential and lack of trustability. Now that we understand the problem more intimately, it's time to turn our attention to patterns that can address them. The issue we want to address first is the inversion of control. The trust that is so fragilely held and so easily lost. Recall that we wrap up the continuation of our program in callback function and hence callback over another part, potentially even external code, and just cross our fingers to do the right thing with the invocation of the callback. This is because we want to. Просто обещание. Ну, просто обещание на 40 страниц так-то. Что можно читать? Окей. Ну, 40 страниц написали? И что, зря писали? Right thing with invocation the callback. With this because we want to say here's what happens later after the current step finishes. What if we could invert the inversion of control? What if instead of handling the continuation of our program to another party, we could expect it to return as a capability to know when its task finishes, and then our code could decide what to do next. Expect what if we could uninvert the inversion of control, but instead of handling the continuation of our program to another party, we could expect it to return as capability to know when task finishes, and then our code could decide what to do next. This paradigm is called promises. Promises are starting to take the JS world by storm, as developers and specification writers alike desperately seek to untangle the insanity of callback hell in their code design. In fact, most new sync IPs being added to JS DOM platform and being built on promises, so it's probably a good idea to dig in and learn them, don't you think? This The word immediately will be used frequently in this chapter, generally to refer to some promise, resolution, action. However, in essentially all cases, immediately means in terms of the job queue behavior, not into strictly synchronous, no sense. Mm. What is promise? When they will decide to learn a new technology on Python, usually the first step is show me the code. It's quite natural of us to just jump in fit first and lower as we go, but it turned out that some instruction get lost. On the IPs alone, premises are one of those tools where it can be painfully obvious from how someone uses it, whether they understand what it's for and about versus just learning and using the AP. So before I show the promise code, I want to fully explain what promise really is conceptually. I hope this will then guide you better as you explore integrating promise theory into your own async flow. With that in mind, let's look at two different analogies for what promise is. Ты изучал другие языки программирования? Ничего не изучал. Future value. In just I woke up to the counter at the fast food restaurant and placed an order for a cheeseburger. Uh, for a cheeseburger. Ты эту книжку не читал? You don't know jazz. I walked to the counter at the fast food restaurant and placed an order for a cheeseburger. I had the cashier 147 by placing my order and paying for it. I have made a request for a value back. I've started transition. Нет, я читал современный учебник JavaScript. Угу. У тебя вообще какой опыт? So hold on onto my receipt and order number. I know it's represents у меня год. Nice. Что ты уже где-то работаешь или чем ты вообще занимаешься за год? So what onto my receipt and order number. I know it's represent my future cheeseburger, so I don't need to worry about it anymore aside from being hungry. While I wait, I can do other things like send a text message to a friend that says, hey, can you come join me for lunch? I'm going to eat a cheeseburger. I'm reasoning about my future cheeseburger already. Even though I don't have it in my hands yet, my brain is able to do this because it's treating the order. My brain is able to do this because it's reading the order number as a placeholder for the cheeseburger. The placeholder essentially makes the value time independent. It's a future value. Компания на позиции backend Node.js. Nice. Хорош. Какой вообще у тебя путь к работе? То есть ты с нуля за год выучил и нашел работу, или у тебя какой-то уже был другой бэкграунд с другими языками? Eventually I hear order. Да, с нуля. А как ты учился? Eventually I hear order 113 and I gleefully Вначале Челси, потом понял, что поздно, начал лучше веб-разработку идти. Мгм. Uh, work up to the counter with receipt in hand. Hand my receipt to the cashier and take a cheeseburger in return. In other words, once my future value was ready, I exchanged my value promise for the value itself. Ну, а как ты веб учил? Только по одной книжке? Или как? Once my future value was ready, I exchanged my value promise for the value itself. So ready, I exchanged my value promise for the value itself. But there's another possible outcome. They call my order number, but when I go to retrieve my cheeseburger, the cashier regretfully informs me I'm sorry, but we appear to be all out of cheeseburgers. Setting aside the customer frustration of this scenario for a moment, you can see an important characteristic of future value that can either indicate a success or failure. Every time I order a cheeseburger, I know that I'll either get a cheeseburger eventually or get the sad news of the cheeseburger shortage, and I'll have to figure out something else to eat for lunch. In code, things are not quite as simple, because metaphorically, the order number may never be called, in which case we are left indefinitely in an unresolved state. We'll come back to dealing with that case later. Нет, YouTube и книжки брал бесплатные заказы для того, чтобы были задачи. Ой, хорош. Бесплатные задачи. Блин, жестко. А где ты находил бесплатные задачи? Ой, заказы. This now or later. This all might sound too mentally abstract to apply to your code, so let's be more concrete. However, before we can introduce new premises working in this fashion, we're going to derive in code that we already understand callbacks, how to handle these future values. When you write code to reason about the value, such as performing math on a number, whether you realize or not, you've been assuming something very fundamental about the value, which is that is a concrete now value already. Писал объявление, что готов бесплатно сделать что-нибудь. Я описывал знания, мне уже писали просто, да. Больше мотивации, nice. Не, ну ты хорош. Как долго ты уже работаешь? Сколько прошло времени с момента обучения и до того, ну, ты начал, и через сколько ты нашел уже работу? Because isn't set yet. Prince assumes both are already set in terms will expound, and shortly we assume the x and y values are already resolved. It would be nonsense to expect that the plus operator by itself would somehow be magically capable of detaching and waiting around until both x and y are resolved. Only then to do the operation. That would cause chaos in the program if a different statement finished now and other finished later, right? 7 месяцев учебы и бесплатной работы, после нашел постоянку. Хорош. А сколько ты собесов прошел? Сложно было вообще в общем найти работу. Give us the reason about their relationships between the two statements if either one or both of them might not be finished yet. If statement 2 relies on statement 1 being finished, there are just two outcomes. Either statement 1 finished right now and everything proceeds fine, or statement 1 didn't finish yet and thus statement 2 is going to fail. If this sort of thing sound familiar from chapter 1, good. 4. Сложно было с английским, если знаешь английский, считай. 50% прошел. Я в натуре. Ты на какую-то зарубежную компанию работаешь или как? Просто типа ко мне люди в чат заходили, которые и без знания английского работают. Но они типа работают, ну, на отечественной компании. Я лишь старался попасть с Кандивеб. А на каком ты сайте искал вакансии? HH, что такое? М, Я с Украины. Careers. Development. Customer experience. Human resource department. Development. О, junior, реально. Да, удаленное тестовое задание несложное. Веб-девелопер. А какая тебе зарплата? И ты джун? Ты типа джуном работаешь? Блин. Девелопер. На связи чисто обсуждать свое тестовое задание не там. Ты ли написал? Да, джун. Ну и сколько тебе платят? Details. О, nice, nice. Cruisers of world known brands. First multiple experience. Если английский есть опыт на старте. Но английский есть. Ну, опыт, ну смотри, ну вот у меня как бы курс идет, да, и здесь куча всяких заданий, проектов. То есть можешь вот GitHub посмотреть. Ну, типа, все, что там есть, это как бы проекты с этого курса. То есть они все дальше и дальше и сложнее и объемней. То есть, в принципе, последний такое задание по JavaScript. Это сделать какой-то типа Инстаграма или страницу какого-то магазина. Ну и типа и то, что я вот, ну где-то, я не знаю, наверное, полгода еще буду проходить. Это The Odin Project, он бесплатный. Наверное, еще полгода буду проходить. Типа это считается как за опыт, то есть, я не знаю, полгода обучения и всяких мини-проектов. Это считается как за опыт? You need to have basic understanding of the web application. Коммерческий опыт. Application built with PHP, MySQL. Блин, PHP. So to being don't expect to start work in the first. You will train, learn, and get feedback and support. Super the way you are. If you have continuous training promos. Если ты сделаешь полноценный сайт типа Магаз, что-то еще, то я думаю, это будет плюс. Мгм. Library requires first based on Magento, but can Shopify that supporting messages. Вначале потом можно перейти. C# вообще. Какой проект поставить? Угу. Да, надо сохранить все. Я учу сначала примерно. Типа учат. Ну, то есть, если они тебя уже взяли на обучение, то есть, ну, то есть, они тебя обучили и все, дают работу. То есть не то, что это какой-то испытательный срок, да, там, обучающий. Что ты там 2 недели поучился, и если там не понравился, то тебя выкидывают. Время обучения тебя. О, найс. Это что за компания? Откуда она? Скандивеб. Латвия. Найс. Надо сохранить. Есть много где. Удаленно можно, да, это круто. А по сколько часов в день ты работаешь? 8 стандарт. И как-то это контролят? То есть, или тебе дают задание, ты там там за 5 его часов сделал, то у них еще по 2-3 миты. Бля, жесть. Хорошо. И долго тебя будут еще, ну, долго ты еще будешь джуном, когда тебе можно будет повышение там до мида взять. Если не контролят экран, не нужно записывать. Угу. Через месяц. А вообще, ну, сложные тебе задания дают каждые 6 месяцев. Бывает, нет. Но какое самое сложное задание ты делал? Мгм. Где посмотреть это? Эм, Тестовое задание. Надо было выгрузить в XML все теги на сайте. Их там пару миллионов, нужно было решить это. Жестко. Было в том, что было ограничение в запись файла. Так. Там раз нельзя было это сделать. А тебе нужно было конкретно за раз сделать все? Списками. Join. It have your own hardware setup. Задача для имида была бы легкой. Угу. Ну, ты справился, молодец. А где посмотреть этот тестовое задание? А сеньору сколько платят? А чё так мало? Когда ты подаешь? Какое у тебя было? Вот. Я вот тоже про такие цифры где-то и думал. Инфа старая. Да не думаю. Им есть смысл старую инфу делать. Ну, все от тебя зависит. Мгм. А тебе зарплату как? Ты сам себе называл зарплату? Либо тебе сказали, вот такая будет и все. Потому что все, с кем я разговаривал на эту тему, то все называли свою цену. Ты сказал 800? 800 дали. Найс. Блин, ну. Блин, звучит как-то ты прям. Как все очень просто на самом деле. Сделал тестовые, тебя ничего не спрашивают больше. И дают работу. Ну, что-то как-то реально звучит ультра легко. Какое у тебя тестовое задание было? Что тебе нужно было сделать? Мгм. Ну, тех собеседований, ты же сказал, что там ничего особо не спрашивают жесткого. Чего тебя там вообще спрашивали? То есть там какие-то задачи ты решал? Потому что все собесы, которые я там на ютубе видел, там сначала тебя как-то по теории спрашивают, потом задачи тебе дают, потом еще что-то спрашивают. Мгм. Магазин книг. А можешь скинуть его мне? Они по коду спрашивали, ну а почему такое решение? О, скинь, пожалуйста. Мгм. Так, let's go back to our x plus y method operation. Imagine if we were was there was a way to say at x and y, but if either of them isn't ready yet, just wait until they are. Add them as soon as you can. Your brain might have just jumped to callbacks. Okay, so X1, X1. Ready. Если не undefined, send along sum. Fetch X and fetch Y are sync or async. Get X. Take just a moment to let the beauty or luck, therefore, of the snippet thing in. Whistled. Whistles patiently. Мы вызываем функцию, аргументом которой есть функция. В этой функции мы x приравниваем к значению. Откуда это значение берется вообще? Imagine if there was a way to say, if the user is ready, just wait until they are. Add them as soon as you can. Function x1. Fetch x, я так понимаю, функция, которая где-то этот x берет. Блин, не понимаю. На гите. Что не можешь? Может ссылку? Если он тебя залит на гид, то можешь ссылку дать? Или он тебя на компьютере? Тогда залей на свой гид и дай ссылку. Well, the ugliest is undeniable. There is something very important to notice about this async pattern. In that snippet, we treated x and y as future values. Snippet, we treated x and y as future values, and we express an operation that from the outside does not care whether x or y or both are available right away or not. In other words, it normalizes the now and later such that we can rely on a predictable outcome of the add operation. Привет and fast. Что, у тебя выходной сегодня? It's just an operation add, and from the outside does not care whether x or y or both are available right away or not. In other words, it normalizes the now and later, such that we can rely on a predictable outcome operation. By using an add is temporally consistent, it behaves the same across now and later times. This sync code is much easier to read about. To put it more plainly, to continuously handle both now and later, we make both of them later. Operations become async. Of course, this rough callback-based approach leaves much to be desired. It's just a first tiny step toward realizing the benefits of reasoning about future values without worrying about the time aspect of when it's available or not. Почти дела уже закончились. Блин, балдежно. Закончились дела в 3 часа дня. Кайф. Что будешь дальше делать? Целый день еще впереди. Ну, 4 тоже как бы середина дня почти. Еще 8 часов ко сну. Ну, плюс-минус так в среднем. Вы, кстати, в компании заказы, ну, с какой, типа, со всего мира принимаете или только там на Россию? Miss Valley. We'll definitely go into a lot more detail about promises later in the chapter, so don't worry if some of this is confusing. But let's just briefly glimpse at how we can express via promise. В теории со всего. Но на практике что-то не получается, да? За пределами православия не нашлось. Жестко. Мгм. Ой, забавно написал ты. Example via promises. А ты, кстати, читал эту книгу You Don't Know Jazz? Потому что все ее очень сильно хвалят. TBH не читал. Что такое TBH? А, To Be Honest, блин. Бля. Уже сегодня и почек, раз время есть. Ай, пипец ты англичанин жесткий. function add x promise y promise. Promise all takes an array of promises and returns a new promise that awaits on them. All to finish. New promise that awaits on them. All to finish. Return promise all. Я не понимаю, а промис это объект, это что вообще такое? When the promise is resolved, let's take the received x and y values and add them together. Что вы на тех митингах делаете? По идее, объект. Я так понимаю, тестово, ну, ты не смог разобраться, да? Как скинуть? Раз день сделали, проблемные зоны. Понял. Return promise, then when that promise is resolved, let's take the received x and y values and add them together. Then function values. Это values. То есть values это вот это, да? Или что? Values is an array of the messages from the previously resolved promises. Is array of message. Ага. Понял. Понял. Return promises for their respective values, which may be ready now or later. We get the promise back for the sum of those two numbers. Now we chain call then to wait for the resolution of that return promise. Вот easier. Да, блин, это выглядит понятно. Okay. There are two layers of promises in this snippet. Fetch x and fetch y occur directly, and the values they return promises are passed into add. The underlying values on those promises represent may be ready now or later, but each promise normalizes the behavior to be the same regardless. We reason about x and y values in a time-independent way. And their future values. The second layer is a promise that add creates. We promise all and returns, which we wait on by calling then. When the add operation completes, are some future values ready and we can print it out. We hide inside of add the logic for waiting on the x and y future values. These are some future value is wrong and we can print it out. We hide inside of add the logic for waiting on the x and y future values. Inside add The premise all call creates a promise, which is waiting on promise X and Y to resolve. The chained call to then creates another promise, which are the return values immediately resolves with the result of the addition. Thus, the then call we chain of the end of the add call and the end of the snippet is actually operating on the second promise return rather than the first one created by promise all. Also, though we are not chaining of the end of the second, then it too has created another promise. Had we chosen to observe it using this promise chaining stuff will be explained in much greater detail later in the chapter. Скину у него в гите уже, давай. Just like with cheeseburger orders, it's possible that the resolution of a promise is rejections instead of fulfillment. Again, start with create React app. Блин, я думал, а есть типа именно как бы список, ну то, что тебе компания выслала, что нужно сделать. То есть я хотел именно, я думал про то, что ты мне скинешь именно список требований и задач. Типа есть у тебя такое? Да, да. JS. This date cache. Интересно. Case add. Case remove. Okay. Components back to cell. Stance components. this product price product attributes шесть. И за сколько ты это задание сделал? Понимаешь, что это друга, а ты за сколько сделал? Ну и друг за сколько сделал? Мгм. А друг? И его тоже взяли на работу? Давно уже там. Like with cheeseburger orders, it's possible that the resolution of a promise is rejection instead of fulfillment, unlike a fulfilled promise where the value is always programmatic rejection value. A commonly called the rejection reason can either be set directly by the program logic or it can result implicitly from a runtime exception. With the promises, the then call can actually take two functions. The first for fulfillment, shown earlier, and the second for rejection. Welcome to Scrum Junior Development Test Assignment. Thank you for interest and time. The overuse task will put you face to face to some common task in development possible. They will get you acknowledged with a bit of new technology. You expect to fetch data from GraphQL endpoint and to provide an interface to view and interact with this data. You can find the endpoint along with instruction on how to launch it. The solution should be implemented as per design. Ёлки-палки, что такое? Как это спрятать? Здесь народу 292 человека. Вроде. Кажется, это просто какие-то ERGO, это просто заметки. Если бы кто-то смотрел, то мышка бы стрелочка бы бегала. Мне кажется, так было бы. Да, это какие-то просто заметки. Here we go. Да, ну примерно видно, да. Ну, выглядит несложно так-то. Типа верстка. Это мне нужно еще React выучить для начала. Другое я сделал жестко, блин. Это нужно, чтобы было адаптивное? Или достаточно просто сделать вот эти 5 экранов и логику? Вообще логику типа там, ну тоже, наверное, да? Типа сделать, добавить в корзину, удалить с корзины. Что такое? Нужно прочитать, что я спрашиваю. Да, да. Endpoint use deliver only entry-level functionalities utilized. You can use setting tag the functionality should be implemented exactly as per design, not necessarily pixel perfect. Although pay close attention to all of the details, there should not be any noticeable mismatches between the design and your implementation, both in terms of design functionality. Think about the implementable functionality in scale. As in real life project, what will happen if you have more than 4 products? The pagination is not expected though. Пагинация это что? Нумерация страниц. Toolkit recommend when select toolkit for this assignment following these guidelines. Mandatory. React and sync not written in React will be rejected automatically. This is React position. Expect React solution. Class components due to our workflow specification. Utilize them heavily. Create React app to scaffold the application. Allowed state management libraries. CSS and JS approach allowed. Allows. Prohibited UI libraries. Functional components due to the reason described above. Functionality requires PLP product list page. PDP product description page. Card page. And some more specific information on the main requirement below. Remember, if something is in the design but it's not explicitly described here or above, it should be implemented anyways. Ability to add, remove products and change their amount in cart and the cards on the cart page itself will be provided for products that have various options. The option should be selected. The selected options, if added to cart products, should be visible in cart overlay in cart page. If an attribute is a swatch attribute. Это что такое? Registration of the value should be rendered on resistant text description. Filtering products by category name. Follow the categories from filtering products by category name. The description provided in HTML format should be parsed and presented HTML, not as plain text. Will to change the currency of the store to one of the available currencies. Not least if you have any questions about this. Окей. Звучит несложно. Наверное, с реактом еще легче, не? Уже бы поскорее к реакту дойти. Но он еще не скоро. Ладно. Задание PHP не нашел. Ну, а ты когда, ну, туда заявку подавал, то ты знал PHP? Так, где я остановился? Угу. Понял. Угу. Окей. Ну, nice тогда. This process actually takes two functions: first fulfillment, the second for rejection. Something went wrong with getting X and Y or something, so somehow failed during the addition. The promise at end returns and rejected. Is rejected the second callback error highly passed. So that will receive the rejection value from the promise. Because promise is obsolete at the time dependent state waiting on the fulfillment rejection of the underlying value from the outside, the promise itself is time independent, and those promises can be composed in predictable ways regardless of the timing or outcome underneath. Moreover, once a promise is resolved, it stays that way forever. Once a promise is resolved, it stays that way forever. It becomes an immutable value at the point and can then be observed as many times as necessary. Immutable value. Как заметки сделать? Ну, окей. Все окей. Окей, ладно. Никак, походу. You because promise extremely immutable once resolved, it's now safe to pass the value around at any party and know that it cannot be modified. Uh, Because a promise is extremely immutable once resolved, it's now safe to pass that value around to any part and how. And now they can be modified accidentally or maliciously. This is especially true in relation to multiple parties. Observing the resolution of promise is not possible for one party to affect another party's ability to observe promise resolution. Immutability may sound like an academic topic, but it's actually one of the most fundamental and important aspects of promise design and should not be casually passed over. It's not like an academic topic, but it's actually one of the most fundamental and important aspects of promise design and should not be casually passed over. That one of the most powerful important concepts to understand about promise. With a fair amount of work, you could ad hoc create the same effects with nothing but ugly callback composition, but that's not really an effective strategy, especially because you have to do it over and over again. Promises are an easily repeatable mechanism for encapsulating and composing future values. Completion event, as we just saw, an individual promise behaves as a future value. Completion event. But there's another way to think of the resolution of promise as a flow control mechanism and temporal this and then that for two or more steps in an asynchronous task. Let's imagine calling the function foo to perform some task. We don't know about any of its details, nor do we care. We complete the task right away, or it may take a while. We just simply need to know when foo finishes so that we can move on to our next task. In other words, we'd like a way to be notified of foo's completion so that we can continue. Сохранить. Typically JavaScript fashion, if you need to listen for notification, you would like think of that in terms of events. So we could reframe our need for notification as a need to listen for a completion. For notification is a need to listen for a completion. Event emitting by foo. Whether you call it a completion event or a continuation event depends on your perspective. Is a focus more on what happens with foo or what happens after foo finishes. Both perspectives are accurate and useful. The event notification tells us that foo has completed, but also that it's okay to continue with the next step. Indeed, the callback you pass to be called for the event notification is itself what we have previously called a continuation, because completion event is a bit more focused on the foo, which more has our attention at present. We slightly favor completion event for the rest of the text. With callbacks, identification would be our callback invoked by the task foo. With its promises, we turn the relationship around and expect that we can listen for an event from foo, and when notified, proceed accordingly. First, consider some pseudocode. Read something that could take a while. Foo completion. Now we can do the next step. What's going wrong in foo? Foo, and then we set up the event listener, one for completion and one for error. The two possible final outcomes of the foo call. In essence, who doesn't even appear to be aware that the calling code has subscribed to these events, which makes for a very nice separation of concerns. Hardly such code would require some magic of the JS environment that doesn't exist. Some magic. Just environment that doesn't exist and would likely be a bit impractical. Here's the more natural way we could express that in JS. Start doing something that could take a while, make a listener identification capability to return. Event on completion function who expressly creates an event subscription. Быстро, да? Специально явно. Creates an event subscription capability to return back. The calling code receives and registers the two event handlers against it. As in version from a normal callback oriented code should be obvious and it's intentional. Instead of passing the callbacks to foo, it returns an event capability we call event, which receives the callbacks. But if you recall from chapter 2, callbacks themselves represent an inversion of control, so inverting the callback pattern is actually an inversion of inversion, where an inversion of control is storing a drawback to the calling code we wanted it to be in the first place. One important benefit is that multiple separate parts of the code can be given the event listening capability, and they can all independently be notified of when foo completes to perform subsequent steps after its completion. Let bar listen to foo completion. Let bus listen to foo completion. You know, an inversion control enables a nicer separation of concerns where bar and bus don't need to be involved in how foo is called. Similarly, foo doesn't need to know or care that bar and bus exist or are waiting to be notified when foo completes. Essentially, this event object is a neutral third-party negotiation between the separate concerns. promise events. As you have guessed by now, if the event listening capabilities and knowledge for a promise in a promise-based approach, the previous snippet would have full, creating and returning a promise instance. And that promise would then be passed to bar and bus. Note, the promise resolution events will listen for aren't strictly events. Resolution events we listen for aren't strictly events, though they certainly behave like events for these purposes, and they're not typically called completion or start doing something that could take a while, construct and return a promise. Function resolve reject, eventually call resolve or reject, which are the resolution callbacks for the promise. The pattern shown with new promise usually called the revealing constructor. The function passed in is executed immediately. Noticing deferred as callbacks to then are is provided to parameters, which in this case we have named resolve and reject. There are the resolution functions for the promise. Resolve generally signals fulfillment and reject signals rejection. You can probably guess what the internals of bar and bus might look like. Listen for food to complete. Promise then it's not finished, so do bar's tasks. Something wrong in full. Promise resolution doesn't necessarily need to involve sending alone a message, as it did when we were examining promises as future values. It can just be a flow control signal as used in the previous snippet. The way to operate this is after finish, so do bar's task. Something went wrong in Fuso. Didn't run. Quito foba. Quito. Mm. If you have seen promise-based coding before, you might be tempted to believe that the last two lines of that code could be written as using a chaining rather than that would have an entirely different behavior, so be careful. The difference might not be clear right now, but it's actually a different async pattern that we have seen thus far, splitting forking. Don't worry, we'll come back to this point later in this chapter. Instead of passing p promise to bar on bus, we use the promise to control when bar and bus will get executed. Use the promise to control when bar and bus will get executed if ever. The primary difference is in the error handling. In the first snippet's approach, bar is called regardless of whether foo succeeds or fails. The first snippet's approach bar is called regardless of whether foo succeeds or fails. Bar is called regardless of whether the first bar is called regardless of whether foo succeeds or fails. Bar is called regardless of whether foo succeeds or fails. The first snippet of bar is called regardless of whether foo succeeds or fails, and it handles its own fallback logic if notified that foo failed. The same is true for bus, obviously. In the second snippet, bar only gets called if foo succeeds, and otherwise oops bar gets called. School. Neither approach is correct per se. There will be case where one is preferred over the other. In either case, the promise P that comes back from foo is used to control what happens next. Moreover, the fact that both snippets end up calling then twice again the same promise P illustrate the point made earlier, which is that promises once results retain their same resolution, fulfillment or rejections forever and can sufficiently be observed in many times as necessary. Moreover, the fact that both snippets end up calling then twice again the same promise P illustrate the point made earlier, which is that promises once resolved retain their same solution, fulfillment or rejections forever, and can subsequently be observed as many times as necessary. Whenever P is resolved, the next step will always be the same, both now or later. То есть я правильно понимаю, что вот здесь у нас в P это промис, ну, допустим, промис с значением 42. Это чисто допустим. И здесь, когда мы вызвали на P, ну, мы вызываем на него Zen, типа если он нормальный, то есть resolved, то выполняется функция bar. И результат этой функции, соответственно, изменяет P. Так? То есть, допустим, в этой функции мы удваиваем это значение. То есть, соответственно, после вот этого действия P становится 84, правильно? Zenable duck typing. In promises length, an important detail is how to know for sure if some value is genuine promise or not. The detail is how to know for sure if some value is a genuine promise or not, or more directly, is it a value that will behave like a promise. An important detail is how to know for sure if some value is a genuine promise or not, or more directly, is it a value that will behave like a promise. Given that promises are constructed by the new promise syntax, Promises are constructed by the new promise syntax. You might think that P instance of would be an acceptable check, but unfortunately there are a number of reasons that is not totally sufficient. Mainly, you can receive a promise value from another browser window, which would have its own promise different from the one in the current window frame, and that check would fail to identify the promise syntax. Moreover, library or framework may choose to vend its own promises and not to use the native ES6 promise implementation to do so. In fact, you may very well be using promises with libraries and older browsers that have no promises at all. When we discuss promises resolution, you can receive a promise value from another browser window, which have its own promise different from the one in the current window frame, and that check would fail to identify the promise instance. Moreover, library or framework may choose to vend its own promises and not use the native ES6 promise implementation. In fact, you may very well be using promises with libraries in older browsers that have no promises at all. Be using promises in older browsers that have no promises at all. When we discuss promise resolution processes later in the chapter. So promise resolution processes later in the chapter will become more obvious why a non-genuine but promise-like value will still be very important to be able to recognize and assimilate. But for now, just take my words for it that it's a critical piece of the puzzle. As such, it was decided that the way to recognize a promise or something that behaves like a promise. Behaves like a promise would be to define something called a Zenable as any object or function which has a then method on it. It is assumed that any such value is a promise confirming Zenable. The general term for type checks that make assumption about the value type based on its shape, what properties are present, is called duck typing. If it looks like a duck and quacks like a duck, it must be a duck. Title of this book series. So the duck typing check for Zenable would roughly be type checks that make assumptions, выводы, да, предположения about, ну, точно, предположение about a values type based on its shape is called duck typing. Look like a duck and quacks like a duck, it must be a duck. type of P object, type of function. Submit available else. Setting aside the fact that this logic is a bit ugly to implement, in various places there is something deep and more troubling going on. If you try to fulfill a promise with an object, with any object function value that happens to have, try to fulfill a promise with any object function value that happens to have a then function on it, but you weren't intending it to be treated as a promise, then you are out of luck because it will automatically be recognized as Zenable and treated with special rules later in the chapter. This is even true if you didn't realize the value has a then on it. For example, V B prototype linked to O. Be some stuff cool, be other stuff not cool. His own property then false. We doesn't look a promise or a then at all. It's just a plain object with some properties on it. Probably just intending to send that value around like any other object. But note to you, V is also prototype linked. This is this object prototypes title of this book series to another object O, which happens to have a then on it. So the thenable duck typing check I will think and assume is thenable. It doesn't even need to be something as directly intentional as that. Object prototype then function, array prototype then function. Both v1 and v2 will be assumed to be thenable. You can control or predict if any other code accidentally or maliciously adds a then. Control or predict if any other code accidentally or maliciously adds a then. Maliciously adds a then to object prototype represent any of the other native prototypes, and if that specified is a function that doesn't call either of its parameters as callbacks, then any promise resolved with such a value will just simply end forever. Crazy sound, implausible or unlikely. Keep in mind that there were several well-known non-promise libraries pre-existing in the community prior to ES6 that happened to already have a method on them called then. Several known non-promise libraries pre-existing the community prior to year 6 that happened to already have a method on them called then. Some of those libraries chose to rename their own methods to avoid collision. Keep in mind that there were several well-known non-promise libraries. Well-known non-promise libraries pre-existing in the community prior to year 6 that happened to already have a method on them called then. Some of those libraries chose to rename their own method to avoid collisions. That sucks. Others have simply been relegated to the unfortunate status of incompatible with promise-based coding in reward for their inability to change to get out of the way. The standard's decision to hijack the previously non-reserved and completely general purpose sounding then property name means that no value or any of its delegates, either past, present, or future, can have a then function present. Either on purpose or by accident, that value will be confused for a thenable in promises system, which will probably create bugs that are really hard to track down. Warning: I do not like how we ended up with duck typing of thenables for promise recognition. There were other options such as branding or even anti-branding. What we got seems like a worst case compromise, but it's not all doom and gloom. Tenable duck typing can be helpful as well as helpful, as we will see later. Just beware that tenable duck typing can be hazardous. If it incorrectly identifies something as a promise that isn't. Promise trust. I have now seen two strong analogies that explain different aspects of what promises can do for our async code, but if we stop there, we have missed perhaps the single most important characteristic that the promise pattern establishes trust, whereas the future values and completion events analogies play out explicitly in the code patterns we have explored. It won't be entirely obvious why or how promises are designed to solve all of the inversion of control trust issues we laid out in the trust issues section of chapter 2, but with a little digging, we can uncover some important guarantees that restore the confidence in the sync coding the chapter 2 tore down. Let's start by reviewing the trust issues with callbacks only coding. When you pass a callback to a utility foo, it might start reviewing the trust issues callbacks only coding. When you pass a callback to utility foo, it might call the callback too early, call the callback too late, or never call the callback too few or too many times, fail to pass along any necessary environment parameters, swallow any error exceptions that may happen. The characteristics of promise are intentionally designed to provide useful, repeatable answers to all these concerns. Calling too early. Primarily, this is a concern of whether code can introduce Zalgo-like effects, where sometimes a task finishes synchronously and sometimes asynchronously, which can lead to race conditions. Promises, by definition, can be susceptible. This concerns because even an immediately fulfilled promise like new promise can be observed synchronously. That is, when you call then on a promise, even if that promise was already resolved, the callback will provide to then will always be called asynchronously. For more on this, refer back to jobs in chapter 1. No more need to insert your own set timeout hacks. Promises prevent Zalgo automatically. Calling too late. Similar to the previous point, the promises then registered observation callbacks automatically scheduled whether either resolve or reject are called by the promise creation capability. Those scheduled callbacks will predictably be fired at the next asynchronous moment. It's not possible for synchronous observation. Synchronous. Почему synchronous читаю? Synchronous. Asynchronous. Asynchronous. Почему я synchronous читаю? Asynchronous. It's possible for synchronous observation, so it's not possible for synchronous chain of tasks to run in such a way to in effect delay another callback from happening as expected. This is when the promise is resolved. All then registered callbacks, when it will be called on in order immediately, and the next asynchronous opportunity again, and nothing that happens inside of one of those callbacks can affect delay the calling of the other callbacks. then function here C cannot interrupt and precede B ABC. Well, B then interrupt and precede B by a virtue our promises are defined to operate. Promise shadowing, right? Quirks. Scheduling. Just want to note, though, that there are lots of nuances of shadowing, where the relative ordering between callbacks, chain of two separate promises is not reliable, predictable. If two promises are both already resolved, it should be true that two promises P1 and P2 are both already resolved, it should be true. It should be true that P1 then would end up calling the callbacks for P1 before the ones for P2, but there are subtle cases where that might not be true, such as the following. Привет, Мимbo. Чем тебе to-do list не нравится? Yes, where that might not be true, such as the following. Resolve B. Resolve A. P1 then. So log B. P2 then. Cancel log V. AB. Not BA. Учим. We'll cover this more later, but as you can see, P1 is result not with an immediate value. But with another promise, P3, which is self-resolved with the value B. Specified behavior is to unwrap P3 into P1, but asynchronously. So P1's callback are behind P2's callback in the asynchronous job queue. Callback behind P2's. What is that? Hmm. P15. P1 вызывает V. P1. Это у нас P3. P3 это у нас B. But another promise to result with the value B, the specified behavior is to unwrap P3 into P1. But asynchronously, so P1's callback are behind P2 in the asynchronous job queue. To avoid such nuanced nightmares, you should never rely on anything about the ordering, shadowing of callbacks across promises. In fact, a good practice is not to code in such a way where the wording of multiple callbacks matters at all. Avoid it if you can. Never calling the callback. It's a very common concern. It's addressable in several ways with promises. First, nothing within a JS server can prevent a promise from notifying you of its resolution. Never calling the callback. This is a very common concern. It's addressable in several ways with promises. First, nothing, not even just error, can prevent the promise from notifying you of its resolution if it's resolved. If you register both fulfillment and rejection callbacks for a promise and the promise gets resolved, one of the two callbacks will always be called. Of course, if your callbacks themselves have JS errors, you may not see the outcome you expected, but the callback will in fact have been called. We'll cover later how to be notified if an error in your callback because even those don't get swallowed. But what if the promise itself never gets resolved either way? What if the promise itself never gets resolved either way? Even that is a condition that promises provide an answer for, using a high-level abstraction called arrays. Utility for timing out a promise. New promise. Use all reject, set timeout function reject, timeout delay, set up a timeout for full promise race. Ooh. Timeout promise. The then function fulfilled in time. Function error either full rejected or it just didn't finish in time. So inspect error to know which. There's more detail to consider with this promise timeout pattern, but we'll come back to it later. Importantly, we can ensure a signal as to the outcome of full to prevent it from hanging our program indefinitely. Независимо? Не принесу. You can ensure a signal as to the outcome of full, calling too few or too many times. By definition, 1 is the appropriate number of times for the callback to be called. The too few case would be a 0 calls, which is the same as the newer case, the never case we just examined. The too many case is easy to explain. The definition one is appropriate number of times for the callback to be called. The too few case would be 0 calls, which is the same as the never case we just examined. The too many cases easy to explain. Promises are defined so that they can only be resolved once. If for some reason the promise creation code tries to call resolve, defined that they can only be resolved once. If for some reason the promise creation code tries to call promise creation code tries to call resolve or reject multiple times, tries to call both, the promise will accept only the first resolution and will silently ignore the subsequent attempts, because the promise can only be resolved once. Any then registered callbacks will only ever be called once each. Of course, if you register the same callback more than once, it will be called as many times as it was registered. Registered. Как это прочитать? Registered. Registered. It was registered. As many times it was registered. The guarantee that a response function is called only once does not prevent you from shooting yourself in the foot. The response function is called only once does not prevent you from shooting yourself in the foot, failing to pass along any parameters environment. Promises can have at most one resolution value, fulfillment or rejection. Is along any parameters environment. Failing to pass along any parameters environment, promises can have at most one resolution value. If you don't explicitly resolve with the value either way, the value isn't defined. This is typically in JS, but whatever the value will always be passed to all registered and appropriate fulfillment or rejection callbacks either now or in the future. Something to be aware of if you call resolve or reject with multiple parameters. Also, this was to resolve with a value either way, the value is undefined. This is typically in JS, but whatever the value, to always be passed to all registered and appropriate fulfillment or rejection callbacks either now or in the future. Something to be aware of if you call resolve or reject with multiple parameters. If you call resolve or reject with multiple parameters or subsequent parameters beyond the first will be silently ignored. Although this that might seem a violation of the guarantee we just described. Resolve rejections with multiple parameters or subsequent parameters beyond the first will be something ignored, although it might seem a violation of the guarantee we just described. It's not exactly, because it's a constitutes an invalid usage of the promise mechanism. Other invalid usages of the IP, such as calling resolve multiple times, are similarly protected, so the promise behavior here is consistent, if not a tiny bit frustrating. Want to pass along multiple values, you must wrap them in another single value that you pass, such as an array or an object. You want to pass along multiple values, you must wrap them in another single value that you pass, such as an array or an object. Pass along multiple values. Want to pass along multiple values, you must wrap them in another single value that you pass, such as an array or an object. As for environment, functions in JS always retain their closure of the scope in which they are defined. See the scope? So they, of course, would continue to have access to whatever surrounding state you provide. Of course, the same is true of callbacks on the design. So this isn't a specific augmentation of benefit from promises, but it's a guarantee we can rely on nonetheless. Ну что за бред? Ты можешь его ставить как все остальное? Swallowing any errors, exceptions. In the base sense, this restatement of the previous point, if you reject a promise with a reason, okay, error message that value is passed to the rejection callback. This restatement of the previous point, if you reject a promise with a reason, error message that value is passed to the rejection callbacks. There's something much bigger at play here. If at any point in the creation of a promise or in the observation of its resolution, just exception error occurs, Any point in the creation of a promise or the observation of its resolution. JS exception error occurs. There's something much bigger at play here. If any point in the creation of promise or in the observation of its resolution JS exception error occurs, such as a type error or reference error, that exception will be caught. Очень сложно. Will be caught. Will be caught. 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 Will be caught. It will be force the promise in question to become rejected. And it will force the promise in question to be rejected. For example, new promise, function resolve reject full bar, foo is not defined, so error. Resolve never gets here. Be then fulfilled. Never gets here. Rejected will be type error exception object. The JS exception that occurs from full bar becomes a promise rejection that you can catch and respond to. This is an important detail because it effectively solves another potential Zonga moment, which is that errors could create a synchronous reaction, whereas non-errors would be asynchronous. An exception that occurs from full bar becomes a promise rejection that you can catch and respond to. This is an important detail because it effectively solves another potential Zalga moment, which is that errors could create a synchronous reaction, whereas non-errors would be asynchronous. Promises turn even JS exceptions into asynchronous behavior. Thereby reducing the race condition chances greatly. Promises turn even JS exception into asynchronous behavior. Thereby reducing the race condition changes greatly. But what happens if a promise is fulfilled, but there is a JS exception error during the observation? So fulfilled, but there is a JS exception error during the observation in a then registered callback, and those aren't lost, but you may find how they are handled a bit surprising until you dig in a little deeper. During this callback, even those aren't lost, but you may find how they are handled a bit surprising until you dig a little deeper. Resolve a then function fulfilled full bar message never gets here either. Wait. That make it seem like the exception from foobar really did get swallowed. Never fear it didn't. But something deeper is wrong, which is that we have failed to listen for it. The P then call itself returns another promise. And it's that promise that will be rejected with the type error exception. Why couldn't just call the error? А ну-ка тут. Ага. Здесь мы прям в новом промисе создавали. Угу. Тут мы тут делаем это. Let's say another promise will be rejected with a type error exception. Why couldn't just call the error handler have defined there? Seems like illogical behavior on the surface, but it would violate the fundamental principle that promises are immutable once resolved. P was already fulfilled to the value 42, so it can't later be changed to a rejection or to a rejection just because there is an error in observing P's resolution. Beside the principal violation, such behavior could break havoc. Разрушение. If say there were multiple then registered callbacks, on the promise P because some would get called and others wouldn't, and it would be very opaque as to why. Здрасте. If say there were multiple then registered callbacks on the promise P because someone get called and other wouldn't, and it would be very opaque as to why. Ну-ка. Ладно, нам прокач там тут объяснят. Ой, жестко, блин. Trustable promise. There is one last detail to examine to establish trust based on the promise pattern. You have no doubt noticed that promises don't get rid of callbacks at all. They just change where the callback is passed to. Instead of passing callback to foo, we get something ostensibly. Как будто бы. We get something ostensibly a genuine promise back from foo, and we pass the callback to that something instead. But why wouldn't this be any more trustable than just callbacks alone? How can we be sure that something we get back is in fact a trustable promise? Trustable than just callbacks alone. How can we be sure that something we get back is in fact a trustable promise? Isn't it basically all just a house of cards where we can trust only because we already trusted? One of the most important but often overlooked details of promises is that they have a solution to this issue as well. Included with the native Year 6 promise implementation is promise resolve. One of the most important but often overlooked details of promises is that they have a solution to this issue as well. Included with the native Year 6 promise implementation is promise resolve. If you pass an immediate non-promise, non-thenable value to promise resolve, you get a promise that is fulfilled with a value. In other words, these two promises will behave basically identically. But if you pass a genuine promise to promise resolve, you just get the same promise back. Неплохо. Even more importantly, if you pass a non-promise thenable value, to promise resolve, non-promise thenable value, to promise resolve, it will attempt to unwrap that value. Attempt to unwrap that value, and the unwrapping will keep going until a concrete final like value is extracted. If you pass it on, it will attempt to unwrap that value, and then unwrapping will keep going until the concrete final non-promise like value is extracted. Recall our previous discussion of thenables. Consider then function CB resembles consider then function CB. This works okay, but only by good fortune. This P is reasonable, but it's not a genuine promise. Likely it's reasonable as most will be, but what if you got back instead something that looked like got back instead something that is reasonable likely it's reasonable as most will be, but what if you got back instead something that looked like mm, then function fulfilled value. This P is tenable, but it's so well behaved of a promise. Is it malicious or is just ignorant of how promise should work? It doesn't really matter. To be honest, in either case it's not trustable as is. Nonetheless, we can pass either of these versions of P to promise resolve, and we'll get the normalized safe result we would expect. Ну как? Почему это так работает? Press resolve accept any tenable and will unwrap it to its non-tenable value, but you get back from promise resolve a real genuine promise in its place, one yet that you can trust. If what you passed isn't already if you passed in is already a genuine promise, you just get it right back, so there's no downside to all downside at all to filtering through promise resolve to gain trust. So let's say we're calling a full utility and we're not sure we can trust its return value to be well behaving promise, but we know it's at least tenable. Promise resolve will give us trustable promise wrapper to chain off will give us a trustable promise wrapper to chain off. Don't just do this. Okay, trust its return value to be well behaving promise, but we know it's at least tenable. Another beneficial side effect of wrapping promise resolve around any function's return value, tenable or not, is that it's easy way to normalize a function call into a well-behaving async task. Side effect of wrapping promise resolve around any function's return value is that it's easy way to normalize that function call into a well-behaving async task. If foo42 returns an immediate value sometimes, or a promise other times, promise resolve, foo42 makes sure it always a promise result. Avoiding Zaga makes far much better code. Блин. Блин, все надо выписать. Полезно это. Не, они просто. Там еще мне задания дают. Как бы читаю, а потом по блоку теории делаю задание. Проект какой-то. Так, это надо вставить. Some reasonable value. Добавляем, уменьшаем. Value. Wrapper. Extract all the previous stack. А практика будет. Практика. Раз, два, три. Через 3 блока теории будем делать приложение с погодой. Так, не понял, что у меня два. Что у меня две эти штуки открыты? Так. Чё, ёпт? Всего лишь 3 блока. Так, resemble but you can resolve a real genuine promise. Once you can trust your promise, get back there is no side. To gain trust, let's say we're calling full utility. Вы не увидишь жестоко. Так а тогда в чем смысл? Если все равно в процессе практики придется читать доку и всю ту теорию. Мгм. Так, face wrapping. Блин, все скопируем, все полезное. Найс. А как ты долго этим занимаешься? Believe the previous discussion not fully resolves, pun intended, in your mind why the promise is trustable and more importantly, why that trust is so critical in building a robust maintainable software. 5+. Nice. Хорош. Памяти. Robust. Крепкий. Can you write a sync code in jest without trust? Of course you can. Jest developers have been coding async with nothing but callbacks for nearly 2 decades. But once you start questioning just how much you can trust the mechanism you built upon to actually be predictable and reliable, you trust to realize callbacks have a pretty shaky now, foundation. Promises are a pattern that augments увеличивает obvious trustable semantics, so that the behavior is more reasonable. The behavior is more reasonable and more reliable. When that augments callbacks with trustable semantics, so that the behavior is more reasonable and more reliable by uninverting the inversion of control of callbacks. Replace the control with a trustable system that was designed specifically to bring sanity to our sync. Все разные кому-то через практику легче, периодически обращаясь к конвертации процесса, кому-то через теорию. Не знаю, мне кажется, просто одно без другого, не работает. Конечно, работает, но хуже. Потому что я сейчас читаю блок информации, мне просто теорию. Типа узнаю, что есть, как оно в теории работает. И потом, когда я перехожу к практике, я как бы плюс-минус понимаю, что от меня хотят и что мне нужно сделать. И уже в процессе, типа, я что-то делаю, соответственно, из-за того, что я знаю это только теоретически, я возвращаюсь к документам, и я знаю, где что искать и что уточнять. И когда ты на практике что-то делаешь и конкретно понимаешь, для чего ты вот это вот прочитал и где это может пригодиться, ты быстро это вспоминаешь, где найти, повторить и сразу вникнуть. Потому что, когда ты много читаешь вот этой практики, ты как бы вроде плюс-минус понимаешь, но как бы не до конца понимаешь, как это имплементировать в реальной жизни. Соответственно, в этом случае практика приходит, и ты уже лучше понимаешь то, что ты прочитал. Тебе уже есть на что ссылаться. Потому что если просто делать практику, то ты, если делаешь практику, то ты ссылаешься и узнаешь только то, что тебе конкретно нужно сделать, но упускаешь из виду то, что есть еще помимо этого. То есть я тут 40 страниц про промисы прочитаю, я не знаю, наверное, это все, что вообще существует про промисы информации. И, соответственно, оно просто у меня будет, я просто буду знать, что это есть, и если я что-то когда-то встречу, то, ну, я уже буду знать, к чему обратиться в документах. Или, или если я это хорошо запомню и пойму, то мне даже ничего не нужно будет обращаться и узнавать заново. Я просто это вспомню. Chain flow. Так, сейчас я в туалет схожу. И в этом есть доля правды, да? Я считаю, очень большая доля. Chain flow. Chain flow. Блин, большой раздел. Chain flow. Error handling. Terminology error handling. Окей. We have hinted at this couple of times already, but premises are not just a mechanism for a single step, this and that sort of operation. That's the building block, of course. But it turns out we can string multiple promises together to represent a sequence of async steps. The key of making this work is built on two behaviors: intrinsic promises. Intrinsic. The key making this work is built on two behaviors: intrinsic to promises. Every time you call then on promise, it creates and returns a new promise, which we can chain with whatever value you return from the then calls fulfillment callback. The first parameter is automatically set as a fulfillment of the chained promise from the first point. Let's illustrate what that means, and then we'll drive how that helps us create a sync sequence of flow control. Consider the following. Promise resolve. Be a then function. Console when fulfill p2 with value 42. By returning, we fulfill the p2 promise that the first then call creates and returned. When p2's then call runs, it's receiving the fulfillment from the return to statement. Of course, p2 then creates yet another promise which we could have stored in a p3 variable, but it's a little annoying to have to create an intermediate variable p2 or p3. Thankfully, we can easily just chain these together. Nice. So now the first then is the first step in a sync sequence, and the second then is a second step. This could keep going for as long as you needed it to extend. Just keep etching off a previous then with each automatically created promise. But there is something missing here. What if we want step 2 to wait for step 1 to do something asynchronous? What if we want step 2 to wait for step 1 to do something asynchronous? Step 2. We're using an immediate return statement, which immediately fulfills the chained promise. And the key to making the promise sequence truly async capable at every step is to recall how promise resolve operates when what you pass to it is a promise or example instead of final value. Promise resolve directly returns a received genuine promise. Or it unwraps the value of a received thenable and keeps going recursively while it keeps unwrapping thenables. The same sort of unwrapping happens if you return a thenable or promise from the fulfillment or rejection handler. Consider it returns it. Even though we wrapped 42 up in a promise that we returned, it still got unwrapped and ended up as a resolution of the chain promise, such as that the second then still received 42. If you introduce asynchrony to that wrapping promise, everything still nicely works the same. You then cancel log, return runs after previous step. Definitely powerful. Now we can construct a sequence of however many async steps we want, and each step can delay the next step or not is necessary. Of course, the value passing from step to step. This example is optional if you don't return an explicit value, and implicit undefined is assumed. And the promises still chain together the same way. Each member's resolution is thus just a signal to proceed to the next step. To further the chain illustration, lets generalize the delay promise creation without resolution messages into a utility we can reuse for multiple steps. The promises still chain together the same way. So let's generalize the delay promise creation without resolution messages into a utility we can reuse for multiple steps. Function delay time, return new promise. Delay time, return new promise. Function resolve reject, set timeout, resolve time. Delay 100 step 1. Then function step 2. Step 2 after 100 milliseconds. Return delay 200. Then function step 3. Next job. Then calling delay 200 creates a promise. It will fulfill in 200 milliseconds, then we return that from the first then fulfillment callback, which goes at the second then's promise to wait on that 200 ms promise. As described technically, there are two promises in that interchange, the 200 ms delay promise and the chain promise that the second then chains from. But you may find it easier to mentally combine these two promises together, because the promise mechanism automatically merges their states for you. In that respect, you could think of return delay 200 as creating a promise that replaces as described technically, there are two promises in that interchange. Described technically, there are two promises in that interchange. The 200 ms that delay promise and the chain promise that the second then chains from. Chains from, but you may find it easier to mentally combine these two promises together, because the promise mechanism automatically merges their states for you. In that respect, you could think of return delay 200 as creating a promise that replaces the earlier returned chain promise. To be honest, those sequence of delays with no message passing isn't terribly useful. Examples of promise flow control. Let's look at a scenario that's a little more practical. Instead of timers, let's consider making Ajax request. In Ajax, что такое Ajax? Web technology on the client side to create asynchronous web applications. Applications can send and retrieve data from a server asynchronously, without interfering with the display and the behavior of the existing page. By decoupling the data interchange layer from the representation layer, Ajax allows by decoupling the data interchange layer from the presentation layer, Ajax allows web pages and by extension web application to change content dynamically without the need to reload the entire page. In practice, modern implementations commonly utilize JSON instead of XML. It's a technology, but rather a programming concept. HTML and CSS can be used in combination to mark up the style information. The web page can be modified by JavaScript to dynamically display, allow the user to interact with the new information. The built-in XML object is used to execute Ajax on the web pages on the website to load content into the screen. Мне кажется, оно не Ajax считается, а Ajax. Ajax. Ajax requests. assume an Ajax URL utility. Promise aware Ajax. А почему я Аякс вообще его читал? Вообще с какого перепугу? Ajax. Вот то лишь Ajax. Function request URL, return new promise. Resolve reject. The Ajax callback should be our promises resolve function. First define a request utility that constructs a promise to represent the completion of the Ajax call. Return request. Then response to. Okay. Developers commonly encounter situations in which they want to do promise-aware async. Commonly encounter situations in which they want to do promise-aware async flow control with utilities that are not themselves promise enabled, like Ajax here, which expects the callbacks. Although the native ES6 promise mechanism doesn't automatically solve this pattern for us. Practically all promise libraries do. Скорее всего, в итоге ты сядешь какой-то смесительный фреймворк в таком контексте. Штук, которые тебе пригодится примерно раз. Ну да, там потом будет React у меня по курсу. JQ. Что такое JQ? Ну, у меня вообще курс full stack. У меня потом так-то еще Node.js будет. jQuery. Но jQuery тут даже и не рассказывают в моем курсе. Потому что сказали, что им уже никто не пользуется. Типа он беспонтовый какой-то. Ну, и Ajax, наверное, тоже не будут рассказывать, что это. Хотя не знаю, ну, типа, может в этих параграфах оно как-то связано и будут рассказывать. Хотя сомневаюсь. Ну, Джейсон тут рассказывают, разве что рассказали. Что такое Джейсон? Хотя, возможно, и расскажут, что просто для общего, да, развития. Чтобы просто понимать, как это работает. И что есть вообще. Так, где остановился? When encounter a situation in which they want to do promise of everything full control with tools that are not themselves promise enable, like Ajax here, which callback, although the native ES6 promise mechanism doesn't automatically solve this pattern for us. Practical promise libraries do. Ну вот. They usually call this process lifting or promisifying or some variation thereof. Come back to this technique later. Ну, вообще, это типа, это You Don't Know Jazz книжка. Сказали прочитать про промисы. Читал ее? Потому что ее все прям ультра нахваливают. Ну, пока, ну, интересно. И более-менее понятно. Using the promise returning request, we create the first step in our chain. Please. Понял. Using the promise returning request, we create the first step in our chain implicitly by calling it with the first URL. Using the promise returning request, we create the first step in our chain implicitly by calling... Implicitly внутренне, да? Неявно, блин. Неявно. By calling it with the first URL and chain of that return promise with the first then. Once response 1 comes back, I will use that value to construct a second URL and make a second request call. The second request promise is returned so that the third step in our async flow control waits for the Ajax call to complete. Finally, we print response to once it returns, and the promise chain we construct is not only a flow control that expresses a multi-step async sequence. We construct is not only a flow control that expresses a multi-step async sequence, but it also acts as a message channel to propagate messages from step to step. What if something went wrong in one of the steps of the promise chain? What if something went wrong in one of the steps of the promise chain? An error exception is on a per promise basis, which means it's possible to catch such an error at any point in the chain and the catching acts to sort of reset the chain back to normal operation at that point. That catching acts to sort of reset the chain back to normal operation at that point. Then в основном используется в синхронных вызовах. Два состояния в конце. Resolve, reject можно чинить, используя callback. Но это я уже понял. Основные приколы я уже понял. Like request, then undefined error never gets here. Never gets here. Так, сейчас. Что еще тут полезно пишу? Ну, пока только это написали. Я, кстати, на русский перевели. Ну, прикольно. Фу. Это мне, в принципе, и на английском нормально. Но я уже тем более половину прочитал. Так. Message console log message. Console log. Так. Function fulfilled. Never gets here. Rejection handler to catch the error. Rejected error. Console log error. Bar 42. When the error occurs in step 2, the rejection handler in step 3 catches it. The return value 42 in this snippet, if any, from that rejection handler fulfills the promise for the next step 4, such that the chain is now back in the fulfillment state. As we discussed earlier, when returning a promise from a fulfillment handler, it is unwrapped and can delay the next step. We discussed earlier, when returning a promise from a fulfillment handler, it is unwrapped and can delay the next step. It's also true for returning promises from rejection handlers, such that if we return 42 in step 3, instead return the promise. In step 3, instead return the promise, that promise could delay step 4. A thrown exception is that either the fulfillment or rejection handler of a then call causes the next chained promise to be immediately rejected with that exception. For when returning a promise from fulfillment handler, it is unwrapped and can delay the next step. It's also true for returning promises from rejection handlers. Such that if they return 42 in step 3, then return a promise, the promise could delay step. Step 4. Throw an exception inside either the fulfillment or rejection handler of a then call causes the next chained promise to be immediately throw an exception inside either the fulfillment Есть ссылка на новую. А кто узнал? First Edition. Does not contain. Не существует такого. На китайском есть первая. Мне кажется, вторая, ну, платная. Тут только первый из этой книги. Ага, он еще не сделал. Да. По сути, я читаю единственное, что есть. Так. Так. То есть это на это воспроизводится, это на возвращает ошибку. И это принимает в rejected эту ошибку, выписывает ее. Это понятно, я понял. Скажи, promise from fulfillment. Тут немного не понял. As discussed earlier, when returning a promise from a fulfillment handler, it's unwrapped and can delay the next step. It's also true for returning promises from rejection handler. Типа оно может типа задержать следующий степ. Типа если мы возвращаем промис. Но оно же и так возвращает промис. Или типа имеется в виду, если мы конкретно промис возвратим, из-за того, что оно его будет распаковывать, оно и будет задерживать следующий степ. When returning a promise from fulfillment handler. Да. Походу так. It's unwrapped and can delay. Ага. Reject handler instead return the promise. That promise could delay. Said either the fulfillment or rejection handler potential call causes the next chain promise to be immediately rejected. The exception if you call then on the promise. You only pass a fulfillment handler to it. It assumed rejection handler is substitute. If you call then on the promise and you only pass a fulfillment handler to it, an assumed rejection handler is substituted. Меняется предполагаемый рабочий команд. Field never gets here. Assumed rejection handler if omitted or any other non-function value pass. As you can see, the assumed rejection handler simply throws the error which ends up forcing P2 the chain promise to reject with the same error reason. In essence, this allows the error to continue propagation along a promise chain until an explicitly defined rejection handler is encountered. You can see the assumed rejection handler simply throws the error, which ends up forcing P2 the chain promise to reject with the same error reason. In essence, this allows the error to continue propagation along the promise chain. Allows the error to continue propagation along the promise chain until the explicitly defined rejection handler is encountered. We'll cover more details of error handling with promises in a little later, because there are other nuanced details to be concerned about. We'll cover more details of error handling with promises later on. If a proper valid function is not passed, if a proper valid function is not passed as a fulfillment handler parameter to then, there's also a default handler substituted. Вызывает, заменяющий. There's also, if a proper valid function is not passed as a fulfillment handler parameter to then, there's also a default handler substituted. P then assumed fulfillment handler is if omitted or any other non-function value passed. Return V. Ничего возвращает. If omitted or any. So you can see the default fulfillment handler simply passes whatever value is received. It receives along to the next step promise. Note the then null function error pattern only handling rejections if any but letting fulfillment path through is a shortcut in the IP. Catch. We'll cover catch more fully in the next section. Let's review briefly the intrinsic behaviors of promises that enable chaining flow control. Intrinsic behavior. Внутреннее, правильно? Да. Enable chaining flow control, and then call against one promise. And then call against one promise automatically. And then call against one promise. And then call against one promise automatically produces a new promise to return from the call. Then intrinsic and then call against the promise automatically produces a new promise to return from the call. Inside the fulfillment rejection handlers, if you return a value or an exception is thrown, the new returned chainable promises result accordingly. If the fulfillment or rejection handler returns a promise, it is unwrapped so that whatever its resolution is will become the resolution of the chain promise returned from the current. Then, while chaining flow control is helpful, it's probably most accurate to think of it as a side benefit of how promise compose. Tool is helpful. It's probably most accurate to think of as a side benefit of how promise compose, combined together rather than the main intent. As we have discussed in detail several times already, promises normalize asynchrony and encapsulate time-dependent value state, and that is what let us chain them together in this useful way. Certainly, the sequential expressiveness of the chain is a big improvement over the tangled mess of callbacks as we identified in chapter 2, but there is still a fair amount of boilerplate шаблоны. Boilerplate then function to wade through. In the next chapter, we'll see a significantly nicer pattern for sequentially flow control expressivity with generation. Так, это удалим. Да, да, вот так. Ух, так, ну это все, конечно, очень интересно, но надо сделать обеденный перерыв. Еще читать и читать. Только половину прочитал за почти 4 часа. Жесть. Так, обеденный перерыв. Ну, скоро вернусь. Тупо, что они убрали, не понимаю зачем, убрали возможность открывать видос, если с колесиком кликнуть. Раньше оно в новой вкладке открывало. Надо сейчас именно по этому, по названию. Это так тупо.
Sorry.
Ой, бляха-муха. Terminology: resolve, fulfill, and reject. There's some slight confusion around these terms. The terms resolve, fulfill, and reject that we need to clear up before you get too much deeper into learning about promises. Let's first consider the promise constructor. As you can see, the callbacks here labeled X and Y are provided. The first usually used to mark the premises fulfilled, and the second always mark. As you can see, two callbacks here provided. The first is usually used to mark the premises fulfilled. The second one is mark the premises rejected. But what they're usually about, and what does this imply about accurately naming those parameters? Ultimately, just your user code and the identifier names aren't interpreted by the engine to mean anything. To your user code and identifier names aren't interpreted by the engine to mean anything. So it doesn't technically matter. Foo and bar are equally functional, but the words you use can affect not only how you are thinking about the code, but how the other developers on your team will think about it. Thinking wrongly about carefully orchestrated, наверное, да? Orchestrated. A single code is almost surely going to be worse than the spaghetti callback alternatives. So it actually does kind of matter what you call them. The second parameter is easy to decide. Almost all literatures uses reject at its name, and because that's exactly and only what it does, that's a very good choice for the name. I would strongly recommend you always use reject. There is later more ambiguity, двусмысленность, неопределенность around the first parameter, which is promise literature is often labeled resolve. The word is obviously related to the resolution, which is what's used across the literature. Literature. Literature is often labeled resolve. This word is obviously literature, including this book, to spreading a final value state to a promise. We have already used to resolve the promise several times to mean either fulfilling or rejecting the promise. If this parameter seems to be used to specifically fulfill the promise, why shouldn't we call it fulfill instead of resolve to be more accurate? To answer that question, let's also take a look at two of the promise IP methods. Resolve creates an promise that resolves to the value given to it. In this example, 42 is a normal non-promise non-thenable value, so the fulfilled promise fulfilled PR is created for the value 42. Promise reject was created the rejected promise reject for the reason oops. Let's now illustrate why the word resolve, such as in promise, resolve is unambiguous, неопределенный, недвусмысленный, недвусмысленный, is ambiguous and indeed more accurate if used explicitly in the context that could result in either fulfillment or rejection. Function, resolve, reject, oops. As we discussed earlier in this chapter, promise resolve will return a received genuine promise directly or unwrap received thenable. If that thenable unwrapping reveals a rejected state, that the promise returned from promise resolve is in fact in that some rejected state. So promise resolve is a good, accurate name for the AP method because it can actually result in either fulfillment or a rejection. The first callback parameter of the promise constructor will unwrap either a thenable, identicative or promise resolve, or a genuine promise. Reject promise, new promise. Resolve this promise with a rejected promise. Fulfill it never gets here. Rejected, console log error. It should be clear now that resolve is the appropriate name for the first callback parameter of the promise constructor. Warning, the previously mentioned reject does not do the unwrapping that resolve. Thus, if you pass a promise thenable value to reject, the untouched value will be set in the rejection section. Rejection reason. A subsequent rejection handler would receive the actual promise thenable you passed to reject. Now its underlying immediate value. The previous mentioned reject does not do the unwrapping that resolve does. If you pass a promise thenable value to reject, that untouched value will be set as a rejection reason. As a subsequent rejection handler would receive the actual promise thenable you pass to reject, know its underlying immediate value. Тут нужно записать. Так вот. Attention to the callbacks provided to then. What should they be called? Was in the literature in called. I would suggest fulfill it and reject it. In the case of the first parameter to then, it's unambiguously always the fulfillment gain, so there is no need for the duality of result terminology. As a side note, the S6 specification uses unfulfilled. There's no need for the duality of result terminology. As a side note, Specification uses unfulfilled. With a fulfillment case. The first parameter to then with the fulfillment. In the case of the first parameter to then is piece of was the fulfillment case, there is no need for the duality of result terminology. As a side note, the S6 specification uses unfulfilled and onReject to label these two callbacks so they are accurate terms. Error handling. We have already seen several examples of promise rejection, either intentional through calling rejector or accidental through JS exception, always all center error handling in asynchronous programming. Let's circle back through and explicit about some of the detail that we glossed over. The most natural form of error handling for most developers is the synchronous try catch. Construct, unfortunately, it's synchronous only, so it fails to help in async code patterns. Try catch could certainly be nice to have, but it doesn't work across async operations. That is, unless there is some additional environmental support, which we'll come back to with generators in chapter 4. In callbacks, some standards have emerged for patterns error handling, most notably the error first callback type. Like some standards have emerged. Try. Right. Hmm. Um, the try catch here works only for the perspective that the will either succeed or fail immediately, synchronously. So it's almost in completing function. Anything arrows inside would not be catchable. The callback we pass to foo. Expect to receive a signal of an error by the reversed first parameter error. If present, error is assumed. If not, success is assumed. Callback will pass to foo expects to receive a signal of an error by the reserved first parameter error. If present, error is assumed. If non-success is assumed, this sort of error handling is technically async capable, but it doesn't compose well at all. Multiple levels of error first callbacks woven together with this ubiquitous if statement checks inevitably will lead you to the perils of callback hell. So we come back to our handling in promises with the rejection handler passed to then. So come back to our handling promises with the rejection handler passed to then. Promises don't use the popular error first callback. Passed to then promises don't use the popular error first callback design style, but instead they use split callback style. There is one callback for fulfillment and one for rejection. While this pattern of error handling makes fine sense on the surface, the nuances of promise error handling are often a fair bit more difficult to fully grasp. Consider numbers don't have string functions, so we'll throw an error. If the message lowercase legitimately throws an error, thus why doesn't our error handler get notified? As explained earlier, it's because that error handler is for the p promise, which has already been fulfilled with the value 42. The p promise is mutable, so the only promise that can be notified of the error is the one returned from p then, which is in this case we don't capture. This shouldn't that should paint a clear picture of why error handling use promises is error prone. It's far easier to have errors swallowed, as this is very rarely what you have intended. If you use the promise IP in a valid way and an error occurs that prevents proper promise construction, the result will be an immediately thrown exception, not a rejected promise. Some example of incorrect usage that fail promise construction. Some examples of incorrect usage that fail promise construction. О, привет, Кузурагли. Чё-то ты поздно сегодня. Вчера пиво с колой попил. This is proper promise construction. The result will be an immediately thrown exception. День. Ничего себе, сколько ты колы выпил. Rejected promise. Risk construction, the result will be an immediately thrown exception. Not rejected promise. Some examples of incorrect usage that fail promise construction. And so on. You can get a rejected promise if you don't use the promise IP validly enough to actually construct the promise in the first place. Лежа укачивала. А сколько ты пива выпил? Как вообще, сколько вообще реально нужно выпить пива, чтобы так... Чтобы в 7 часов прийти. Ну, у тебя, наверное, больше уже. Ну, у тебя уже ночь, так-то уже, наверное, около 10. Это мой вопрос. Ох, вести. Ты жесткий. Тикток даже сломался. Ты кадр. Еще колебали. И форму. Ой, меня порвало. Как поживаю? Ну, 40 страниц промисов я читаю. Половину уже прочитал. Ой. Ох, ты ж, блин, выдал. Да. Это эта книга. You don't know jazz. Дали по курсу прочитать главу. То, что Сиран, если помнишь, говорил, что прочитал в чате. Ой. У него про наследование говорил. Да, это тоже... У этой книги миллиард частей. Где это оно? Она даже на русском есть вроде. Блин, подожди. 6 частей. Scope enclosures, this object prototypes, types and grammar. Тоже почитать хотел. Как будто Learn.js все закрывает. Ну, Сиран как бы тоже, ну, как бы прочитал эту книжку, но он уже прочитал, когда он уже как бы, ну, мидом работает. То есть тут, наверное, больше типа освежить знания и, может быть, посмотреть на что-то с другой какой-то точки зрения. Ну или может здесь какие-то прям ультра мелкие детали написаны, которые, ну, возможно, ты не знал. Когда он сказал про наследие, я посмотрел, и ровно то же самое, что на Лерне, да. Блин, ну здесь, блин, не 40 страниц, блин. Здесь 2. Не знаю, 3. Дальше еще есть. Наверное, тогда вот это все, наверное, вот это в эти 40 страниц и входит, потому что для промиса вот сколько подзаголовков. И промис траст, и чейны, и error handling, и паттерны, IP, limitations, single resolution interior, микрозадачи, синхронщик. Часть ивент лупа. Микрозадачи. На очередь. Ну, типа, ну, event loop это типа создается просто очередь задач, и когда выполняется одна, она как бы выполняется и дается, и переходит к следующей. Это же правильно? А ну скинь. Здесь после выполнения текущего кода, если нужно гарантировать выполнение. Ну. Ну, пока что то, что, ну, Zen вообще понять. То есть у меня пока что с Zen, ну, то есть логично, пока выполняется одно, действие переходит к следующему. Если выдается ошибка, то ошибка сразу перескакивает к функции, которая ловит эту ошибку. А, на час видос. Ой, не очень лейте. Давай посмотреть. А про нодовский можно не смотреть или тоже посмотреть, если я нот еще не дошел. Если я нот еще не знаю. Так, ну 45 минут. Надо будет потом посмотреть. Так, где я остановился? Then president use the popular first design style with sense split callback style. Ладно, давай. Удачи тебе там с формами и с похмелья. Попей колы, реально. Спасибо. Так. The news promise a bit more difficult to fully grasp. If you use promise IP in a valid way and recurs that prevent proper promise construction, the result will be an immediately thrown exception, not a reject promise. Prevents proper promise construction, the result will be an immediately thrown exception. Some examples of incorrect usage that fail promise construction. And so on, you can get a rejected promise if you don't use a promise IP validity validly enough to actually construct a promise in the first place. This is because the term could live. Let me fulfill the product notified to their error is the one returned true. Handles south. Mm. But years ago, programming languages often set up in such whether by default developers fall into the pit of despair, the pit of success, this pit of as my first pit of despair. Programming language unmanaged makes it so easy to fall into traps. To fall into traps, think buffer overruns, memory leaks, double freeze, mismatch between allocator and deallocator using read memory 10,000 ways to trash or heap, and those are just some. Where accidents are punished and that you have to try harder to get it right. He implored us to instead create a bit of success where by default you fall into expected successfully action and those would have to try hard to fail. Promise error handling is unquestionably a bit of despair design. By default assumes that you want any error to be swallowed by the promise states. And if you forget to observe that state, the error silently languishes, thus in obscurity, usually despair. To avoid losing an error to the silent of a forgotten, discarded promise, some developers have claimed that the best practice for promise chains is always end your chain with a final catch like. To the silence of forgotten, discarded promises, some developers have claimed the best practice for promise chains is to always end your chain with a final catch like. Merge then string functions. So we didn't pass rejection handler to the or to the then the default handler was substituted, which simply propagates the error to the next promise in the chain as such. Both errors that come into P and errors that come after P in its resolution like the one will filter down to the final handler errors. Right, not so fast. What happens if handler error stuff also has an error in it? Catches that there's still yet another unintended promise. The one catch returns which we don't capture and don't register rejection handler for. You can't just stick another catch on the end of the chain because it's too could fail. The last step in any promise chain, whatever it is, always has a possibility, even decreasingly so, of dangling with an uncaught error stuck inside an observed promise. Sound like an impossible conundrum yet. Uncaught handling. It's not exactly an easy problem to solve completely. There are other ways to approach it which many would say are better. Some promise libraries have added method for registering something like a global unhandled rejection handler, which would be called instead of a globally thrown error, but their solution for how to identify an error as uncaught is to have an arbitrary length timer. Some promise libraries have added method for registering something like a global unhandled rejection handler. Method for a method for registering something like a global unhandled rejection. Unhandled rejection failure, which would be called instead of globally thrown error, but their solution for how to identify an error as uncaught is to have an arbitrary length timer, say 3 seconds, running from time of rejection. If a promise is rejected but no error handler is registered before the timer fires, then it assumed that you won't ever be registering a handler, so it caught. In practice, this has worked well for many libraries, as most usage patterns don't typically call for significant delay between promise rejection or an observation of that rejection, but this pattern is troublesome because 3 seconds This pattern is troublesome because 3 seconds is so arbitrary, even if empirical, and also because there are indeed some cases where you want to promise to hold on to its rejectedness. Patterns don't typically call for a significant delay between promise rejection and observation of rejection, but this pattern is troublesome because 3 seconds is so arbitrary, even if empirical, and also because there are indeed some cases where you want a promise to hold on to its rejectedness for some indefined period of time, and you don't really want to have your uncalled handler called for all those false positives, not yet handled uncalled errors. Another more common suggestion that promises should have a done added to them, which essentially marks the promise chain as done. Done doesn't create and return a promise, so that though the callbacks past to done are obviously not worried up to report problems to a chain promise that it doesn't exist. So what happens instead? It's treated as you might usually expect in unquote error conditions. An exception inside a done and rejection handler would be thrown as global unquote error. Inside a done and rejection handler would be thrown as a global unquote error. Uh, message handlers, it would be thrown globally here. This might sound more attractive than the never-ending chain of arbitrary timeouts, but the biggest problem is that it's not part of the S6 standard, so no matter how good it sounds, at best it's a lot of longer way off from being a reliable and ubiquitous solution. Ubiquitous. Что за слово? Ubiquitous. 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 Вездесущий. Ubiquitous solution. Are we just stuck then Not entirely. Browsers have unique capability that our code does not have. They can track and know for sure where any object gets thrown away and garbage collected, so browsers can track promise objects. And whenever they get garbage collected, if they have a rejection in them, the browser knows for sure this was a legitimate uncode error and can thus confidently know it should report it to the developer console. At the time of this writing, both Chrome and Firefox have early attempts at that sort of uncode rejection capability, though support is incomplete at best. However, if a promise doesn't get garbage collected, it's exceedingly easy for that to accidentally happen through lots of different coding patterns. The browser's garbage collection and sniffing won't help you know and diagnose that you have silently rejected promise laying around. Is there any alternative? Yes, bit of success. Блин, вот это жестко что-то происходит. Bit of success. If only just theoretical how premises could be someday changed to behave. I believe it will be far superior to what we currently have. And then the following is just theoretical. Premises could be someday changed to behave. I believe it would be far superior to what we currently have, and I think this change would be possible even post ES6 because I don't think it would break web compatibility with ES6 promises. You probably feel. А какого года вообще эта книга? 4 года назад. Нет. А, Promise could default to reporting to the developer console any rejection on the next job or event loop tick if at the exact moment no error handler has been registered for the promise. default to reporting to developer console any rejections on the next job or event loop tick. If at that exact moment no error handler has been registered for the promise. For the cases where you want a rejected promise to hold on onto its rejected state, we want a rejected promise to hold on to its rejected state for an indefinite amount of time. Before observing, you could call defer, which suppresses automatic error reporting on that promise. The promise is rejected as it defaults to noisily reporting that fact. Promise is rejected, it defaults to noisily reporting that fact to it defaults to noisily reporting that fact to developer console instead of defaulting to silence. You can opt out of that reporting either implicitly by registering an error handler before rejection or explicitly with defer. In this case, you control the false positives. Hmm. What was then? That when to wait while to use observe its rejection. So we call differ. Thus no longer reporting differ simply returns the same promise for a changing purpose. The premise returned from foo gets an error handler attached right away, so we simplicity opt out and no global reporting where it occurs either. But the premise returns from the then call has no defer or error handler attached, so if it rejects from inside either resolution handler, then it will be reported to the developer console as an unquote error. This then is a pit of success, where all errors are either handled or reported. What almost all developers in almost all cases would expect. You either have to register a handler, or you have to intentionally opt out and indicate you intend to defer error handling until later. You're opting for that extra responsibility in just the specific case. The only real danger of this approach is if you defer a promise but then fail to actually ever observe handle its rejection. You had to intentionally call defer to opt into that pit of despair. The default was the pit of success, so there is no such else you could do to save you from your own mistakes. I think there's still hope for promise errors handling. I hope the powers that be will rethink this situation and consider that this alternative. In the meantime, you can implement this yourself, a challenging exercise for the reader, or use smarter promise library that does for you. This exact model for error handling is implemented by any sequence promise abstraction library, which will be discussed in Appendix A of this book. Шеф, туалет. Certain promise of all kinds. Which errors in the same manner if given the second argument. With the error handler, we should place catch exactly in places where we want to handle errors and know how to handle them. The handler should analyze errors. Custom errors classes help. And rethrow unknown amounts. Maybe they are programming mistakes. It's okay not to use catch at all if there's no way to recover from an error. In any case, we should have the unhandled rejection event handler for browsers and analytics for other environments to track unhandled errors from the user and probably are sorry about them so that our app never just dies. Promise chains upgrades at error handling when the promise rejects the control jumps to the closest rejection handler. That's very convenient in practice. For instance, in the code below the URL, the fetch is wrong. No such site and catch handles the error. As you can see, the catch doesn't have to be immediate. It may appear after one or maybe several then, or maybe everything is alright with the site, but the response is not valid. JSON, the easiest way to catch all errors, is append to the end of the chain. Normally such catch doesn't trigger at all. Wait. Normally such catch implicit try catch. The code of promise executor and promise handlers has invisible try catch around it. If an exception happens, it gets caught and treated as a rejection. For instance, this code works exactly the same as this. It works exactly the same as this. press resolve, reject, reject new error. Oops. Now the invisible error catch around the executor. The method catches the error and turns it into rejected promise. This happens not only in the executor function as well. If you throw inside it then handler, that means a rejected promise. The control jumps to the nearest error handler. Here's an example. If you throw inside a then handler, that means a rejected promise. Control jumps. No errors, not just those codes, but it's also, for example, programming error. Nice. То есть теперь они пофиксили это. You already noticed catch, and then the chain is similar to try catch. You may have as many then handlers as we want, and then use a single catch at the end to handle errors in all of them. In the regular try catch, we can analyze the error and maybe throw if it can be handled. The same thing is possible for promises. If you throw inside catch, then the control goes to next closest error handler. If you handle that error and finish normally, it continues to the next closest successful then handler. The example below, the catch successfully handles the error. To the next closest error handler. If we handle normally, then continues to the next the error. So the next successful then handler is called. In the example below, we see the other situations with catch. The handler catches the error and just can't handle it. He only knows how to handle to throw it again. Jumps from the first catch to the next one. Handled rejections. What happens when an error is not handled? For instance, we forgot to append catch to the end of the chain, like here. In case of an error, the prompt becomes rejected and the execution should jump to the close the rejection handler. There's none, so the error gets stuck to handle it. In practice, just like with regular unhandled errors in code, it means that something has gone terribly wrong. What happens when a regular error occurs? It is not called by try catch. The script dies with the message in the console. A similar thing happened with unhandled promise rejections. JavaScript engine tracks such rejections and generates a global error in that case. You can see it in the console if you run the Explorer above. Such rejection generate a global error in that case. You can see it in the console. In the browser, we can catch such errors using the event inlet rejection. It's the special properties. The object promise functions you do error no catch to handle the error. Then this is a part of the Shima standard. If an error occurs and there is no catch, the unhandled rejection alert triggers and get the event object with information about the error, so we can do something. Usually such errors are unrecoverable, so our best way is to inform the user about the problem and probably report the incident to the server. In non-browser environments like Node.js, to track when error occurs and there is no catch, the rejection handler triggers and gives the event object with the information about the error, so we can do something. Usually such errors are unrecoverable, so our best way out is to inform the user about the problem and probably report the incident to the server. In non-browser environments like Node.js, there's other ways to track unhandled errors. Catch handles errors in promises of all kinds, be it a reject call or an error thrown handler. Reject call or an error thrown handler. Then also catches errors in the same manner. If given the second argument, which is the error handler, we should place catch exactly in places where we want to handle errors and know how to handle them. The handler should analyze errors, custom error classes help, and rethrow unknown ones. Every time we want handlers and no one handles them, the handler should analyze service custom classes. Help and return normal ones. Maybe their programming mistakes escape not to use cache at all if there is no way to recover from error. In any case, we should have the unhandled rejection event handler for browsers and analytics for the other environments to track unhandled errors and inform the user and probably our server about them, so that our app never just dies. Я думаю, да. Ну, блядь, почему? Ну, set timeout. As said in the chapter, there's an implicit try-catch around the function code. So all synchronous errors are handled. But here the error is generated not while executor is running, but later, so the promise will handle it. Synchronous errors are handled. It's just default reporting that fact to the developer console. You can opt out of that reporting either implicitly. Я понимаю, это пофиксили, да. Promise all. Um, in a sequence promise chain, only one async task is being coordinated at any given moment. Step 2 strictly follows step 1 and step 3 strictly follows. But what about doing 2 or more steps concurrently in parallel? In classic program terminology, a gate is a mechanism that waits on 2 or more parallel concurrent tasks to complete before continuing. It doesn't matter what order they finish in, just that all of them have to complete for the gate to open it and let the flow control through. In the premise API, we call this pattern all. Say you wanted to make 2 AJAX requests at the same time and wait for both to finish regardless of their order. Before making the third AJAX request, consent. Also expects a single argument and array consistent generally of promise instances. The promise returned from the promise all call with receive fulfillment message in this snippet. And the promise returned from the promise all call will receive a fulfillment message. That is an array of all the fulfillment messages from the past in promises in the same order of as specified regardless of fulfillment order. Technically, the array of values passed into promise all can include promises, the enables, or even immediate values. Each value in the list is essential path through promise resolve to make sure it's a genuine promise to be waited on, so an immediate value will just be normalized into a promise for that value. If empty, the main promise is immediately fulfilled. Actually, the list is essentially passed through promise resolve to make sure it's a genuine promise to be waited on. This is replaced through promise resolve to make sure it's a genuine promise to be waited on, so an immediate value will just be normalized into promise for that value. If the array is empty, the main promise is immediately fulfilled. The main promise returned from promise will only be fulfilled if and when all its constituent Constituent. Promises are fulfilled if any one of those promises instead is rejected. The main promise is immediately rejected, discarding all results from any other promise. Remember to always attach a rejection error handler to every promise, even and especially the one that comes back from. Return handler to every promise, especially the one. The promise currently assumes all are needed for fulfillment. Sometimes you only want to respond to the first premise to a cross. To cross the finish line, letting the other promise follow where this pattern is classically called a latch. But in promise this is called race. Well, the metaphor of only the first across the finish line wins. Once fits the behavior well. Unfortunately, race is kind of a loaded term. What a metaphor of only the first across the finish line wins fits the behavior well. Fortunately, race is kind of loaded term because race conditions are generally taken as bugs in programs. Don't confuse promise race with race condition. Promise case also expects a single array argument. Promise race also expects a single array argument containing one or more promises, variables or immediate values. It doesn't make much practical sense to have arrays with immediate values because the third one listed with obvious because the first one listed will obviously win. Immediate values. The first one listed will obviously win, like a foot race where one run starts and the finish line. I will fulfill if and when any promise resolution is fulfillment, and will reject if any if and when any promise resolution is rejected. A race requires at least one runner, so if you pass an empty array instead of immediately resolving the main race promise will never resolve. This is a foot gun. Yes, should have specified this that either fulfills reject or throws some sort of synchronous error functionally because of precedence of in promise libraries. Присутствие. Приоритет. Precedence. Promise libraries predating ES6 promise. They had to leave this gashi in there, so be careful never to send in an empty array. Let's revisit our previous concurrent Ajax example. Параллельный, одновременный, да? But in the context of a race between P1 and P2. A request is a promise of Ajax utility, like we defined earlier in the chapter. The difference between we can define early in the chapter. Message. Чему на месседж возвращает? Because only one promise wins, the fulfillment value is a single message, not an array is. So this example early illustrating how promise race can be used to express the promise to mouth pattern. So this early illustrating how promise race can be used to express the promise to mouth pattern. Function might promise. Defined earlier returns a promise it rejects after a specified delay. Set up a timeout for foo. So raise foo. Timeout promise. Give it 3 seconds. Attempt foo, then function. Therefore rejector it just didn't finish in time. So inspect error to know which. but some nuances to consider, and frankly, they apply to both equally. Finally. The key question to ask is what happens to the promises that get discarded, ignored. To the promises that get discarded. Ignore, we're not asking that question for the performance perspective. They would typically end up garbage collection eligible. But from the behavior perspective, side effects, etc., promises cannot be cancelled. And shouldn't be as that would destroy the external immutability trust discussed in the promise uncancelable section later in this chapter, so they can only be silently ignored. But what if with the previous example is reserving some sort of resource for usually, but the timeout fires and causes that promise to be ignored. The previous example is reserving some sort of resource for user, but the timeout fires first and causes that promise to be ignored. Is there anything in this pattern that proactively frees the reserved resource after the timeout or otherwise cancels any side effects it may have had? What if all you wanted was to log the fact that full timeout? Closed promises needs a finally callback registration, which is always called when a promise resolves and allows you to specify any cleanup that may be necessary. This doesn't exist in the specification at the moment, but it may come in. Have to wait and see. A cool like In various promise libraries, finally still creates and returns a new promise to keep the chain going. If the cleanup function were to return a promise, it would be linked into the chain, which means you could still have the unhandled rejections issues discussed earlier. In the meanwhile, we could make a static helper utility that lets us observe without interfering the resolution of promise. Сейчас есть такое? Promises as shadows a function to be called when the promise is settled and immediately returns an equivalent promise object, allowing you to chain calls to other promise methods. Let you avoid duplicating code in both the promises then and catch handlers. We take a static helper utility. Визуальф. Такого нету. Нету такого. So I use it in the timeout example from before. Helper is just an illusion of how you could observe the completion of promise without interfering with them. Other promise libraries have their own solutions. Plus, how you do it, you likely have places where you want to make sure your promises aren't just silently ignored by accident. Versions of all in race. Well, native yes, 6 promises come with built-in promise all and promise race. Well, native yes, 6 promise comes with built-in promise all and promise race. There are several other commonly used patterns with variation on these semantics. None is like all, but fulfillment and rejections are transposed. All promises need to be rejected, become the fulfillment value, and vice versa. Cool, but it ignores any rejections, only one needs to fulfill instead of all of them. First, Учим any. Hey, we should. The first promise fulfills last. Some promise abstraction libraries provide this, but you could also define them yourself using the mechanics of promises. Промис any. Есть такой? Есть. А почему мне не выдало? А не выдало. Any first. This race takes the first settled promise. Then it is faster. Define first. Single check. Function. Return your promise. Promise for each. For each promise. Resolve. Whichever one fulfills first wins. Gets to resolve the main promise. Expectation of first does not reject if all Its promise reject simply hangs much like a promise raise does. If desired, you could add additional logic to track each promise rejection. And if all reject, call reject on the main promise. We'll leave that as an exercise for the reader. Concurrent iteration. Sometimes you want to iterate over a list of promises and perform some task against all of them, much like you can do with synchronous arrays. You want to iterate over a list of promises and perform some tasks against all of them, much like you can do with synchronous arrays. Some and every task to perform against each promise is fundamentally synchronous. This work fine. So fine just as we used for each in the previous snippet. But if the tasks are fundamentally asynchronous or can should otherwise be performed concurrently, you can use async versions of these utilities as provided by many libraries. Tasks are fundamentally asynchronous. Synchronous or can should otherwise be performed concurrently. You can use async versions of these utilities provided by many libraries. For example, let's consider an asynchronous map utility that takes an array of values, could be promises or something else, plus a function task to perform against each map itself, returns a promise whose fulfillment value is an array that holds in the same mapping order the async fulfillment value for each task. It waits for all mapped promises. Not regular array map turns the array of values into array of promises. Walls map Mouse map function well. Replace results after valve is a thing mapped. Present results after all is async mapped. New promise. Resolve. Go back. This implementation of map you can't signal a sync and rejection, but if a synchronous exception error occurs inside of the mapping callback, the main promise map return promise would reject. Let's illustrate using map with a list of promises instead of simple values. Values in a list even if they are promises. Promise done. Show the item itself is a promise. Extract value as v. Done. Choose a done. Name to promise rejection message. Function vals. Что за done, я не понимаю. Как это вообще работает done этот? Как? Ну, map, я понимаю, мы берем array и в callback функцию. Callback функцию берет promise из array. Promise из array. Потом этот промис превращает в промис. Ну, проверяет его. Превращает в промис, короче. Потом на этот промис мы вызываем функцию. Вот это я уже не понимаю. А что за дан? Что оно, как, откуда, блин? Вот callback function, я понял. Вот это вот vals, а вот это callback function. И нам map возвращает promise all, возвращает array, где для каждого value, то есть для array value он вызывает map, и на каждый value вот этого array он возвращает новый promise. Вот это я не понимаю уже. Что значит CB valve resolve? Values plus a function task to perform against each map. Promise whose fulfillment value is an array that holds in the same mapping order. In this possession of map, you can't signal async rejection. Exception error occurs inside of the mapping callback. The main promise map return promise would reject. Is read using map with a list of promises. Да, прикол. Прикол. Я это уже завтра не хочу уже. Уже устал читать. 7 часов читать. Кто-то объяснит, как вот это работает? Без вот это вот. Это я понимаю, и на каждый value мы превращаем в промис. Но return new promise function resolve. Почему просто не писать return promise resolve val? Что CB значит? Я и забыл про него. Polyfill. Что такое polyfill? Piece of code Spread modern functionality in older browsers. Чё, Promise Map существует? Text and array of values and the callback function is parameters. Callback функция. Ну вот это я понимаю. Set the promise map function, the evals map method. Iterate over each value in the evals array for each value is created using promise construct that the promise is resolved asynchronously by calling the CB function with the current value and the resolve function as the argument. The resolve function is used to resolve the promise after the value has been processed. Using called over the array of promises returned by the this creates a new promise that resolves when all promises in the array have resolved. Finally, promises returned by the function. In summary, the promise map function was used to apply a synchronous operation to each value in an array and get a promise that resolves when all the asynchronous operations have completed. This code is useful in situations we need to perform a synchronous operation in multiple values in parallel. Ну, интересно, но я что-то тут туплю, не могу понять. Что такое promise map? Типа, Он мне выдал, что это полифил. Типа полифил, короче. Но, блядь, не существует промис-мапа никакого. Так что какой может быть полифил на то, что не существует? You provide a polyfill for promise map function. It has the promise map method for the promise prototype if it doesn't. А, нет. Не, все, я понял, что такое полифил. Я думал, полифил это когда ты превращаешь функцию, типа, которая поддерживается в новых браузерах, функцию, которая поддерживается в новых браузерах, ты переписываешь ее так, чтобы она поддерживалась в старых браузерах. The code provided is a polyfill for promise map function. It adds the promise map method. Так есть, да? Тогда я что-то не понимаю вообще тогда. The code you provided is a polyfill for a promise map function. It adds the promise map method to the promise prototype if it doesn't already exist. Я понял. То есть это мы создаем абсолютно новый метод. Окей, хорошо. Один пункт я понял. То есть мы создаем то, чего не существует в априори. И типа этот мэп, что он делает? Он берет array и превращает этот array в array промисов. И вот тут я не понимаю, смотри. Типа вот, promise map. Мы берем функцию, ну типа это функция, которая берется array значений и callback функция. И что нам эта функция возвращает? Нам она возвращает array промисов. Promise all. Promises. И теперь мы для каждого значения из этого массива пробегаемся. Теперь для каждого этого значения мы вызываем вот эту функцию, которая возвращает нам новый промис. И вот это я не понимаю, что это. То есть она нам возвращает новый промис. И как бы, ну, промис resolve, я так понимаю, типа вот это она делает, да? Возвращает новый промис, который, ну, которая выполняет функцию resolve. И в этой функции resolve она возвращает cb value resolve. Я вот это вообще не понимаю, что это. Если я тебя запущу. Я как бы понимаю результат, который он мне даст, но я не понимаю, как он это делает, понимаешь? Ну вот, как бы тут и показывает, что он нам возвращает-то массив. Массив промисов, правильно? Я конкретно не понимаю вот это. То есть callback функция, которая берет вот эти вот Ну, короче, функция, которая что-то делает с этими значениями. И эта callback функция принимает значение value и resolve. И чё? Чё дальше? Если нам нужно просто промис. Если нам нужно просто это значение в промис превратить. То есть вот эта функция в действии. Мы передаем array. Anything else. The related quotes. То есть она берет array. У нас есть два промиса resolved и один rejected. Соответственно, callback функцию. То есть вот это и есть вот этим. Но как? То есть promise resolve promise. Я вообще не понял. То есть эта функция берет вот этот промис. Я вообще запутался. Ты тут? Не выдержал. Человек не выдержал. Завтра продолжим. Всем спасибо. И всем